All right, everyone, welcome to lesson 4 in Unit 5. So just look for the fourth lesson in your Unit 5 book. I unfortunately don't know the page, as usual, because I don't have the book that you have. Okay, so we're just going to be looking at functions again, but this time with graphs. Okay, so the warm-up says, what do you notice and what do you wonder about this graph? So you could pause the video here and like write down what you think before you hear me explain what I think. That'd be fine. And if you end up just deciding to write your own thing, that's cool too. So I would say the first thing I notice is that the lines go, oops, I didn't mean to do that, in different directions. Also, the lines are not straight. Okay. You could say, I noticed that one starts at the origin here and that one starts 72 seconds at 72 seconds, or ends at 72 seconds. I guess it would start at here at around 200 meters. So they start in different places. You could say that as well. Okay. So this graph, or this question for this one, is just what might this graph represent? And what they want you to do mostly is just focus on the axes, the labels. So one says T and then the other one says H, inches. So that's like pretty much they want you to be able to look at that and say, this graph is showing, inches per month. Whether or not that's like rainfall, growth of some plant or something, or maybe of a person or an animal. They just want you to understand that you can look at the axes and kind of come up with an idea about what the problem is about before you have to start solving the problem, because if you don't really understand what they're saying in the beginning, then when you go to start solving it, you're just going to be even more confused. So yeah, I hope that kind of makes sense, why they want you to do that. It is important to know. And then later on in this lesson, we're going to talk about the independent, dependent variables and which one typically goes with which graph. So you guys can kind of memorize that, and that'll kind of help you understand too. Okay. Equations and graphs of functions. So you probably have a better picture in your book, or a bigger picture, but it says match one of these equations to each of the graphs. So we're not really going to be doing much like calculating for this. We're just going to look and kind of guess. And we're going to go through all three because I think that this is kind of a lot to expect that you guys would be able to do this without really any instruction on it from your book, and probably having forgotten this from whatever year you learned it in. So right away I'm looking at the three graphs and I see that one of them is curved and the other two are not. One of them looks like it has a positive slope. This one looks like it has a negative slope. And then graph A is curved, so I already know that that's going to be a different kind of thing. So A says D equals 60t, where D is distance. You want to travel in t hours if you drive at 60 miles per hour. So I know that's going to have to be something that has positive slope. And if I look at 1 and I draw it up and across, that's right at about 60. So it's safe to say that A goes with graph B. And then B says Q equals 50 minus 0.4D, where Q is the number of quarters and D is the number of dimes. A pile of coins worth $12.50. So if we were to rearrange this, you could say Q is negative 0.4D plus 50. And, oh, geez. Okay, there. Oh my gosh, what's happening? Okay, so 50 is your intercept, right? Your y-intercept. And this is your slope. Well, cool. It's a negative slope. And a y-intercept of 50. So that means that goes with C. I hope this is kind of making sense. So you don't really have to do any math per se. You just have to kind of like use your common sense about graphs to kind of like eliminate it. And this is actually a really good skill for test taking. And you guys are going to have so many computer tests in high school. So this is a good practice for things like that, where it's just like you can quickly eliminate things, because there are a lot of questions that will come up on standardized tests, not to get off task, but that will be like this. And then you guys are going to immediately go to like, oh my God, I have to like solve all of this and come up with something. And really, if you just look at it and you kind of know what to look for, you can save yourself tons and tons of work. So anyways, the last one, A equals pi r squared, where A is the area in a square centimeters of a circle with radius. Okay, well, process of elimination, we know that that has to go with A. And we haven't really worked with graphs like that very much, but that's typical of a graph where something is being squared because of the pattern of, you know, what happens when you square a number and square different numbers continuously. You're going to get something that's like an upward sloping graph like this. So yeah, don't worry too much about like the math behind that right now, because we're not really there yet. Number 2 says label each of the axes with independent and dependent variables and the quantities that they represent. So just as a general rule, and I'm just going to tell you this so you don't have to be confused, you can just memorize this. Independent variables always typically go with the horizontal axis. So independent usually go with the horizontal axis. So that would be the one going, here I'll highlight the pink. That's horizontal, right? So for example, let's look at B, because that's an easy one. You could say that that's time, and then that's distance. So time would be the independent variable, and then the dependent variable, dependent variable is the vertical one. So just think of it as like, okay, so like distance equals something time. So essentially the one that is all alone on the other side is depending on whatever is smushed between all the numbers on the other side of the equal sign. That's kind of how I remember it, but you can remember it whichever way makes sense to you. But yeah, independent's always horizontal and dependent's always vertical. Can't think of a situation where they would try to confuse you, and if they do, I will let you know. Okay, for each function, what is the output when the input is 1? And what does this tell you about the situation? Label the corresponding point on the graph. Okay, so that means that we just have to plug in the number 1 into the equation and then solve, if that makes sense. So we could do 1 together, and then you guys can do the rest. Okay, so what's a good one? Let's look at the first one. Okay, so you have D equals 60t. So they're saying input is 1. So our input is 1. That means that goes with t. So D equals 60 times 1. Distance equals 60. So that's how that would work. And they just want you to do that for B and for C. So like plug in 1 where D is for B, and then plug in 1 where R is. I hope that makes sense. And I'm just checking right now to make sure I told you the right thing in the answer key. just in case my knowledge is wrong. Looks like it says, what number? B, no, we're on number 3. Okay, number 3. Okay. Number 4, find 2 more input-output pairs. What do they tell you about the situation? Label the corresponding points on the graph. Find 2 more input-output pairs. What do they tell you about the situation? Find 2 more input-output pairs. What do they want you to do? We might skip this one because I have to teach myself that to be able to tell you how to do it. Okay, skip that. I will just waste 10 minutes of this video trying to figure out how to tell you how to do that, so skip. Okay, running around a track. We're on activity 3. So Kieran was running around this track. The graph shows the time he took to run various distances. The table shows his time in seconds after every 3 meters. Okay, so how long did it take Kieran to run 6 meters? So if I look at my graph, I go to 6 meters here. It looks like it took him 2 seconds to do that. Does that make sense? I'm just reading the table. So you could say it took him 2 seconds. How far had he gone after 6 seconds? So I find 6 seconds here. He has gone 18 meters. Oops. And then I want you guys to try C and D on your own. And then what does it say? Is Kieran's time a function of the distance he has run? Explain how you know. This one you would say yes. And then you're going to say something about how, yes, I know this because for every specific distance, there's one specific time. So it's the whole thing about functions is that you have one input, you have one output. You don't have multiple different outputs for one input. So in this case, the table is super clear. You have 1 for 1, and so that works as a function. Okay, running around a track again. So this time, I'm going to have you guys try to do most of this one on your own. But it says Priya is running around once around the track. The graph shows her time given how far she is from her starting point. So the first part wants to know what was her farthest distance from her starting point. So the farthest distance that Priya ever traveled, if that makes sense. So the farthest distance that she ever traveled was here, the end, which this is going in gaps of 25, and this should be 200 here. So 200 meters. Estimate how long it took her to run around the track. So for that one, you're going to look to here, right? And you're going to write down what you think that number is. For C, estimate when she was 100 meters from her starting point. So that means that you find 100 meters, which is here, and then you follow it up to here, and then what value is that? That's how you do C. And then D, estimate how far she was from the starting line after 60 seconds. I want you to try to do that one totally on your own. For E, it says, is Priya's time a function of her distance from her starting point, and explain how you know. And we're going to do this one because this one's kind of tricky. So when you look at this graph, there's 2 different times corresponding to the distance of like let's say like 100 meters. There's like 2 different times or whatever you choose. So because of the fact that there's more than one time option, you would say no. And then you need to explain what I just said. So no, because, oh, this pen. My goodness. No, because she had multiple time options for that one distance. And in a function, you can only have one, right? So you can't have more than one. All right, lesson synthesis. So this is like generally what we wanted to walk away, being able to say, I can use a graph of a function to find the output for a given input. We did that. Okay, I can identify graphs that do and do not represent functions. For example, because I have a feeling this is going to be confusing for people. This whole lesson is pretty confusing. I apologize because I did not write this book. It's not the best book, but it's what we have. So, this graph is not, right? Because you've got like two things going on at once. You can't have two different times for one distance. I mean, you can, but then it's just not a function. And for this one, it's for sure a function, right? Because it's like, it's obvious. Like I could go and highlight like this distance equals this time, like this distance equals this time. It's like very cut and dry. It's one for one. So that is why that's a function. As far as plugging things in to get answers, we kind of did that a little bit over here for number 3, where they want you to find the output. So just to kind of go over that again for people who are confused, we're looking at this question that I circled in green. They're just trying to say, like, I'm going to give you the variable value and you're going to plug it in. But instead of telling you what variable you're supposed to plug it in for, they're just kind of like assuming that you can kind of figure that out, if that makes sense. So for 3, like what we did for A, they're telling you, where are they telling you? D equals 60 times T. So the output is going to be that dependent variable, the one that is waiting for information. Independent variable is T. That's how I knew to put the 1 into the T. If you get confused 9 times out of 10, you're just plugging whatever the information is into what is on the other side of the equal sign from that variable that's all alone, if that kind of makes sense, from the variable that's depending upon all the other information in that part of the equation. So that's kind of how I figured that out. So for the other ones, try B and C. So for this, you still have to do B and C. We just did A. All right, I think that's it. I hope that made sense. Definitely do the practice problems. And if you get stuck and you need help session at 1:40, just let me know.